All right, good morning, everyone. Let's go ahead and get started. Um, so I just want to kind of survey the room a little bit because we've got two kinds of guns up here today, a regular air spray gun and then an air-assisted airless. How many use the air spray, low pressure? And how about the air-assisted? All right, and who's just here to learn about the electrostatic technology who's not using it? All right, quite a mixed bag. All right, so we're going to start with the air spray, and then we'll move into the air assisted. A couple of things about the Graco product line of guns is they are air driven technology. In other words, there's no power supply somewhere else that's sending a low voltage to this gun. There's a turbine in the back of the gun using air supply. That turbine is going to generate a small voltage, and that small voltage is going to go out to the amplifier where it's going to bring it out to a larger capacity, anywhere from 40 kV up to 85 kV. Basically, if you look at the difference of the sizes of this gun, you can see one's longer than the other. That's because the amplifier here is longer, which means it's going to create a bigger voltage. So the higher voltage you go up, the bigger the physical gun's going to be, okay? The other thing that's unique about electrostatic guns is the airline that comes up to it. That airline is going to provide air for two things, actually three. One, the air that drives the turbine, okay? Two, the air that creates atomization. And three, the air that gives you the fan pattern, okay? Because this is an electrostatic gun, we also need to provide grounding. So the air hose that feeds this gun is the ground point for the gun. The ground point for the operator is the handle. Okay, so that's a conductive handle that needs to be in contact with the operator's palm. And that means if you're wearing a glove, you got to cut a hole out in the palm, or you have to have a wrist strap, something that connects that operator to the palm. Okay, that provides the safety. So if you're getting electrical shocks, and trust me when I say electrical shocks, it's not like you're putting your finger in an wall outlet, right? It's more of a tingly feeling. It's not comfortable, but it's not going to kill you either, right? Generally speaking, that's because you've got a bad ground. Okay, and it could be the operator, it could be the gun, whatever. That ground is coming through this air hose. That air hose is a left-handed thread, so you can't put the wrong air hose on here. However, that doesn't mean that there isn't a problem with the air hose. If you got the right air hose on there and you're getting these shocks, sometimes you got to check the ground from here to a true earth ground to make sure your hose is still good. Okay? All right, and that's the same with the air-assisted airless gun. All right. The other thing I'd like to talk a little bit is about the paint itself. Usually when you purchase an electrostatic gun, somebody along the line has tested your paint to make sure that it's going to work with your electrostatic gun. However, as you go through and maybe change or update the paint you're using, sometimes people forget, hey, we got to make sure this paint is qualified for electrostatic guns. And that's where the meters come into play. This is a new meter we just launched this week. This year. You may see some older meters that are analog, just like any meter that you might have in your toolbox. Old meters were analog, newer meters are digital. This one's now a digital one. Okay, you just got to test it to make sure that it's within the range. And there's a couple of different meters out there. Whatever meter you're using, make sure you have the range guide with you to tell you that, yeah, this material is within range for electrostatics. If it's too conductive, meaning it's going to pass electricity too easy, basically what happens is the probe out in the front of the gun is the charge point, which is in contact with the paint, and that charge will carry back through the fluid tube to this point right here, which is a ground point, and that'll short the gun out. Doesn't damage the gun, doesn't hurt anything. It just takes a very expensive gun and turns it into a very inexpensive air spray gun, okay? On the other side is if it's not conductive enough, then it won't carry the charge at all, okay? So any paint that goes off the gun isn't carrying the charge, which negates all the benefit of the electrostatics. Really important, check your paint resistivity, especially if you're changing to a new paint, okay? The other thing that happens over time is when you first get electrostatic guns and you deploy them and you set them up and you're like, holy crap, these things work awesome, right? You know, you're wrapping around the part, your transfer efficiency goes way up. But over time, all of a sudden things start changing, right? And your wrap starts to go down, your transfer efficiency starts to go down. And a lot of that is due right back to grounding, because when you're painting something that's conductive, the part, right? And that part is hanging by a hook that's going up to a conveyor, that's your ground. So what do you suppose is happening over time? Yeah, you're getting paint buildup on your hooks, right? And when you get that paint buildup on your hooks, you don't get a good ground to part anymore. And all of a sudden, your transfer efficiency starts being effective. So making sure you take care of your complete system and keeping it clean is paramount to the productivity of this gun, okay? A couple other things about the gun. Part distance from the gun is important. Generally, you want that tip to be about 10 inches from the part that you're painting. If you get too far away, what do you suppose becomes the closest grounded target? Yeah, the operator. So when you start getting what we call wrap back to your arm or body, a lot of times it's because, number one, either the ground is poor or the painter's too far away from the part, okay? If you get too close, electrically your gun starts physically connecting to the part, which means all of a sudden this becomes a ground, which again shorts the gun out and it'll paint, but you won't be getting the charge any longer, because the voltage is going down and the amperage is spiking. Okay, all right, so that's just some basic operations. The one thing that I want to show you here, as we were talking about paint resistivity and being super conductive, you'll notice that this gun here has a shorter fluid tube to the ground point. I know it's hard to see from back there, but this has got this big sleeve on here. We actually make a clear one that's a little bit easier to see. This is an older style. But if you look up in here, you'll see the fluid tube is much longer than this, and it's just coiled up. All we're doing is putting a longer fluid tube between here and here, adding paint resistance so that voltage can't travel back through this tube and short out to the base. So for those materials that are sketchy, close to being too conductive, this gun solves that problem. All right, I'm going to go ahead and start talking about the gun itself now. I'm going to move these out of the way so they're not a distraction. I'm going to go ahead and remove this cap. By the way, best practices when you're doing anything to this gun for flushing, cleaning, loading, take the cap off. When you're flushing, when you're cleaning, when you're loading, there tends to be a certain amount of spitting, paint, air, solvent, and that spitting can get up into these caps, plugging these air holes. So best practices whenever you're doing anything other than painting, take this cap off. Another best practices is on the nozzle. If you're going to take that nozzle off, pull the trigger. We want to pull that trigger to get that needle or that needle off the seat. If you leave that needle on the seat and you start spinning this seat off, you're putting undue stress or wear on that area, and that's going to wear that component out a little bit quicker. So, and that's not just for this gun, that's for any gun, that's for any valve. Wherever there's a needle seat, when you take it apart, get that needle off the seat just to give you the longest expectancy of that part. Okay, the nozzle assembly has got a couple things on the back of it. One is going to be an O-ring, and the O-ring for sealing, and the other is going to be an O-ring for passing the KV out to the electrode, okay? The one ring is going to be a conductive ring. It's going to come in contact with a little piece of metal that's up in the front of the gun, and it's going to pass it to the inside of this nozzle. I'll pass this around, and I'll pass also a small Allen wrench as well. You can take a mega ohm meter or a meter, and you can actually, from this conductive ring to the inside of this, you can check the resistance. And I don't recall what it is off the top of my head. You'll have to look in the manual, but it'll call out a resistance factor in here. And if it's outside of the scope, that means you should replace this. By the way, you can check this gun with that same meter from the base of the gun to the electrode. And again, you should have a specific resistance through that gun, depending on what model it is. And if it's within the window, you're good. If it's not, then you have to do what we're going to do today, take it apart and check all the components. So I'm going to pass this along, and if you just take this Allen wrench and just kind of run it through the center, you're going to feel a rough edge. That rough edge is the conductive ring in this nozzle that passes from this ring out here all the way to the inside. So I'll start over here if you want to grab that. Next thing I'm going to do is I'm going to take the electrode off. That electrode is tied to the packing assembly in here, and sometimes when you try to spin this off, the whole assembly spins. So in order to stop that, you can put some side pressure on this trigger or just pull the trigger. And that's going to capture that needle assembly. And then you can use your tool, which comes with every gun, and you can spin this electrode off. And the electrode is also the needle assembly. So there's the electrode. There's the little feet that come in contact with the inside of that nozzle that pass the KV out to this electrode. This is the sealing surface right here for the nozzle. All right, this is a snapback electrode, so it can take quite a bit of movement and come right back to center. However, it's not completely not bendable, right? If you completely bend this over, it's going to stay bent. It'll take a lot of abuse, but not 100% abuse. If this needle gets bent, replace it, okay? Because if it's bent like this, that fluid comes across, it should flow across with the needle assembly. If it's got to break across it because it's bent, you're going to disrupt that fluid stream, and that fluid stream is going to do this. And when it does that, it takes it outside of the atomizing area, and it also takes it outside of the ionization area. Okay, so this is a very important piece to make sure that is in good shape. This is also an electrical component that you can test by putting that meter from one of these legs out to this needle, and there's again a very specific resistance. If it's outside that window, replace it. You've got a job to do, and you've been sleeping over there. But it's a good thing you're sitting next to him to poke him. All right, next thing I'm going to do is I'm going to take this trigger assembly off. All right, we'll set that aside because now I can go ahead and take my tool again and I can pull out the needle assembly. All right, this is the whole needle assembly. You can purchase this as an assembly like this, or you can buy a rebuild kit and you can take that packing off and rebuild this. My suggestion is replace this, the whole thing. Couple of reasons. If this is leaking, chances are that this has got some wear on it anyways. It's just best to replace the whole thing. When you put this together, if you're not replacing it, when this whole thing slides in, there's a drag spec on here. How many of you guys have drag wrenches? Very, very few, if any, right? When you put this together, number one, make sure there's dielectric grease loaded in here, and then tighten it down by hand, and then take some wrenches and give this another quarter to a half turn. That should give you the right spec, drag spec, or something very close to it, okay? But just make sure when you're done that it still moves. This little nut back here, that's your lead lag adjustment. That's factory set. You should never have to adjust it. But if you do adjust it, that means when you pull the trigger, you're changing when the atomizing air comes on and when the fluid comes on. When you pull that trigger, you want the air to come on and then the fluid to follow. When you de-trigger, fluid goes away, then air goes away. That eliminates what we call spitting. If you get in here and adjust it and you get those two too close together, you're going to get paint spit, okay? Again, that's factory set. You should never have to change it, but just be aware of that's what that does. When you put the trigger assembly back on here, make sure that trigger assembly is sitting in front of that nut. Attaboy. All right, I'm going to disconnect the fluid now. I'm not going to disconnect it from the front of the gun. You don't need to disconnect that to take this gun apart. You can. Make sure you put dielectric grease back up in here if you do. This is a pretty long-winded thread, so if you don't need to take it apart, leave it on there. There's 2 screws on the back of this gun, and these 2 screws is what is holding the front of the gun to the handle. And it's double threaded. In other words, it's threaded into the handle and then into the front of the gun. You are just removing the screws from the front of the gun. You don't have to completely remove them from the handle. Once they're loose, you can go ahead and pull the front apart. This one's got the black seal in it. This was new probably about 4 or 5 years ago. If you've got older guns, it may be a white one. That white seal was susceptible to damaging pretty easily. These are much more robust. When you take these apart, there's really not a lot to service on this part of the gun other than cleaning it, and then making sure that that spring is intact right here. If you look down in here, way at the bottom, you're going to see that there's a metal, looks like a BB, it's a little rod, and that metal rod comes out to the front of the gun. That's the connection point or the voltage pass point, okay? All right, from here I'm going to go ahead and take the electronics out of the gun, and there's 2 pieces here. One is that turbine I talked about, and the other is the amplifier. You can, once again, take a meter and test it from one or the other of these metal tabs out to the spring in the front of this, and depending on the voltage of the gun, 40 to 85 kV is going to determine what that resistance should be. This is polarity sensitive. In other words, and if you put the meter on here backwards, it's not going to read, okay? So just be aware of that. This is the turbine. This is the device that creates the small voltage through this ribbon cable, passes it to the other part, the amplifier, and creates the large voltage. You can put a regular ohm reader on this, and that should measure between 5 and 7 ohms on the outer terminals. More critical to that is the bearings in here. You're typically not going to see the resistance change in the windings here, but you're going to see the bearings wear over time. You can rebuild these. There's a little snap in the back, and everything will pull out the back, and you can replace the bearings. Most people just replace this whole device. Okay, we'll pass these around. This one is got that dielectric grease on it, so I'll just kind of wrap it in this. All right, at the base of the gun, back here is going to be the on-off, and what that's for is to disrupt the air to the turbine. If you want to shut the electrostatics off, you're going to turn the switch over. That's going to kill the air to the turbine, which is going to stop the KV. You're going to do that if you're trying to paint into a corner to avoid that Faraday cage, okay? There's O-rings and a spring and the air valve that are located behind this. The other thing on here is there is an adjustment knob. That adjustment knob is used to limit travel of the trigger. That should be only used if you're trying to do touch-up or cut-ins. If you're restricting the needle to get the right flow rate from the gun, that means you've got too large of a needle for your application, and you should really downsize, because during full production, you want this wide open. If you're restricting that needle during full production, you're going to be wearing out needle nozzles quicker than you should. Okay? Pull that off, and again, I'm not going to pass some of this around because that's kind of boring. It's just a plunger with some O-rings and a spring that sits out in front of it. But once that's out, I can just push the air valve right out the back of the gun, and that's your air valve. In front here is the U-cup for the air valve. If you're feeling air on your hand when you pull the trigger, That's because this U-cup is failing, okay? I'll pass this around and look at the U-cup, and you'll notice that there's a U and flat on one side, a U shape and then flat. Whenever you have a U-cup or a V-stack for that matter, you always want those sealing edges, that U or that V, inward to where the pressure is that you're sealing. Excellent, thank you. I think that's the last thing I'm going to pass around. You're going to notice that there's a couple of valves over on the side here, restrictor air valves. I'm not going to take those off. There's only a O-ring on there for repair. But what these are is you've got a fan adjust and an atomization adjust. These knobs will allow you the ability to adjust the atomizing air or adjust the fan air out to the air cap, because we need at least 55 PSI going to the turbine to get the right voltage. 55 PSI is good for the turbine, not so much good for the air cap. So we use these to restrict that air from the air cap so you don't over atomize. All right, so at a component level, that's pretty much it for the air spray gun. So as those components are being drug around the room, I just want to check for any questions or comments before we go into the rebuild. Yeah, good question. So I think that needle assembly and the nozzle. So first of all, the needle assembly with the packing on it, the needle nozzle, and quite frankly, the turbine as a complete kit, or at least a rebuild kit.
What are the most common parts that fail, and what is is it just a replacement or the entire?
Yeah, so the most common is probably going to be the packing rod.
What's the life expectancy of that? Just cleaning it well and everything just like normal?
Yeah, so and I get that question a lot, and not just with guns, with pumps, with proportioners, with everything, right? And my standard answer, and I hate the answer, but it's the right answer, is it depends, right? And it depends on a couple of things. The paint, right? If I'm using a zinc-rich epoxy primer, I might be repairing that gun once a month. If I'm using a really standard paint that doesn't have a lot of fillers or a lot of solid content, that gun may last a year without having to service it. What do you suppose the two biggest factors are in any kind of repair? Gun, pump, whatever. Well, lack of maintenance for one, for sure. Lack of care, right? I'm thinking of two other really big ones, but lack of care is a good one. The product that you're running through it, including the air, right? If you got crappy air, it's going to be detrimental to the operation. If you got good, clean, dry air, that's very helpful, especially in guns like this where you're running air through that turbine, right? Okay. And along with, exactly. So along with care of the gun, right? Proper care of the gun, who's doing the proper care of the gun? The operator. The operator is the number one detriment to or positive of life expectancy to the gun. I've been out to customer sites where there's two painters in one gun, and one guy's painting on this side, and then when he's done, he flips the gun on the ground underneath the part to the other painter, and then they paint that side, right? Well, how long do you suppose that gun lasts? Not very long. Yeah, exactly. The tool, yeah.
Have any issues with like getting guns in flush boxes, getting the material back up in the air passages?
It can. That's one of the reasons I always like to take this guy off. Yep. It goes right back to care, right? So if from the gun flush box, if you have a hose that goes to a bucket or wherever, and that is non-restricted, you get good passage, right? But over time, it's right, and that's going to cause back pressure and backflow. So it goes right back to preventative maintenance and care.
What do you actually use to clean it? That would be my next question. Is it just compressed air that you're flowing the powder back out of it?
No, well, it's not powder, so it's if you're used to powder, it's different, right? We're using solvent. Okay. Yeah. And as far as care goes, one of the big mistakes that I see people doing when they're cleaning this gun is you can't go after this with a bottle of solvent, right? You don't want to squirt solvent all over this gun. This gun is solvent resistant, not solvent proof, okay? Which means if I take a rag and I start wiping it down, you're okay. But if you start squirting solvent on it or dunking it in a bucket of solvent, you're gonna have problems. Also, when you're cleaning it, point it down. Don't leave it up like this, because if I'm cleaning it and I've got a rag or a solvent and I'm spraying it, where's that solvent going? Right back down the air passages. And where do you suppose that air passage leads? Right to the electronics of the gun, exactly right. So really good question. It depends on the paint you're using and the solvent base of the paint. One of the biggest problems I see is customers using either low-grade solvent or reclaimed solvent. And I'm not here to bash reclaimed solvent. Reclaimed solvent has its place in our world. I think when it comes to cleaning products like this, you need to flush it with really good solvent recommended by your paint supplier.
Do they want to come back with a non-polar solvent afterwards with this unit?
Not necessarily, yeah. Another really good question, I would say if we're talking about an automatic gun, especially rotary atomizers, yes. Not so much this gun. I don't know if everybody understood the question about non-polar solvents being okay to flush with this gun. It is. You're not spraying that either highly polar or non-polar solvent. You're just using it to flush. But one of the things that you do need to do is make sure the electrostatics are turned off when you're doing it.
No, a gun would fault out on itself if you did.
It will. It will. Yeah. Yeah. But in the end, we just never want the electrostatics on with a highly polar solvent. Yeah. Yes. The actual number, I guess I'm not too sure. I don't know, is Wendy in the room? Maybe she has a number. Do you know what that number is? Yeah. So first of all, on the back of the gun, there's a light. Okay. That light is either going to be amber, green, or red. Amber means it's spinning too slow. Put a little more air to it to get it to go green. If it goes red, it's spinning too fast. Okay. Now, that doesn't mean that it's dangerous. It just means, because we're clipping the voltage here, so you can't over voltage the gun. It just means you're spinning that turbine too fast and you're going to burn those bearings out quicker than if it was green. What that range is for the green, I don't remember off the top of my head. I'd have to look it up.
Yeah, so these don't have a cascade inside them? We were calling it a...
It's the same thing.
Okay.
Yeah, same thing. Yeah. How are we doing on the parts? Still passing around, or have they stalled out somewhere? Still passing? Good. Yeah. Other questions or comments? Wendy, am I forgetting anything we should be talking about before we start rebuilding? That's a good question. There is not a high conductivity kit for the AA gun. And that is because the probe, and I'll pass this around when we get to it, is outside of the fluid stream. So in its original design, it's considered high conductivity. In fact, I'll just go ahead and pass that around right now, so everyone can see what I'm talking about. There should be a tip in this cap, and it's not. So it's not generally a big hole right there. There's usually a tip there. What I really want you to look at is where that probe is, and it's outside of the tip so the fluid isn't in direct contact with it.
Was that service tool that would pass around almost every gun?
Yes. Yeah, and so does the Allen wrenches. There's 2 Allen wrenches that are required for the gun, and all 3 of those come.
Would you say the air spray or the air assisted airless is the more popular gun?
I'm going to let Wendy answer that question. By the way, I didn't introduce Wendy. Wendy's the product manager for all guns, including electrostatics. Thank you, sir.
More to come.
More to come. All right, so I'll keep going while I'm waiting for the components for the air spray. This one looks a little bit different. It's got a much smaller needle or nozzle assembly, and that's because it's one size fits all. We don't control the flow using this anymore like we did on this one. The flow is now controlled by the tip that's in that air cap. This is just an on-off. However, like I said, the on-off, which somebody still got the tool, so I'll just, that's okay, keep it going around, I'll just use this wrench. By the way, this is kind of a cardinal sin that I'm doing.
I was gonna say.
Yeah. Why do you suppose that is?
Because it gets scarred after.
Yeah, exactly right. Use that tool or use a socket here or a box end wrench. Don't do this, right? I knew it was loose, so I knew it was gonna come pretty easily. But there's your nozzle. And then the needle is down inside here, okay? I'm gonna go ahead and pull this apart just like the other gun. Because we're using a tip with the AA gun, there's actually a fluid filter built into the handle. That's just to catch anything big that might plug that tip up.
So what's the little needle or whatever that's in the end of that?
That's the probe.
That's the actual probe?
That's the actual probe, yep. If you look down on the back side of it, yeah, you're gonna see it's bent over, and that bent over piece comes in contact with the ring in the front of the gun here.
That's actually giving the charge.
Correct, that's passing the charge off. All right, so this part of the gun right here is no different from the air spray gun. So I'm not gonna take this apart any further. Everything that we did on the air spray holds true here as well. So I'm just gonna set that aside. This is a little bit different, obviously, high pressure hose. And then we've got this cap on the back. That cap is holding in the needle assembly.
Real quick question,
Mhm.
do you have to replace this whole piece to replace the electrode?
That's a 2-piece.
Two-piece, so it comes apart?
Yeah, that cap actually comes off the base, yeah. Okay, so I take the cap off along with the spring, that's a spring return. Down inside, and this is the other Allen wrench that comes with the gun. It's a much smaller one. And this is a little counterintuitive when you pull this apart because of the design of this. Usually when you're unscrewing something, you're not pushing in at the same time, and that's because there's a 2-piece design in here, kind of floats, and when you're unscrewing it, you're pushing it and unscrewing it so these 2 pieces come together and connect. You'll see that as soon as I pass this around, but as I was turning this, I pushed it in, and that pushed in, those 2 pieces connected, and now I can unscrew the needle assembly. And then what I was talking about is these 2 pieces right here. You'll notice when I pass it around, if you just spin it around, you'll see they align and then push together. And that's what allows you to connect it and unscrew the whole thing. So here's the 2 pieces. Oops. And from there, that's all there is for the differences of the 2 guns. This piece does not come off the front of the gun. You can, You can put something on here and you can grab it and you can spin it off and then we'll sell you another one. Okay? I guess we can pass this piece around too so everyone can see this. You've done a great job, by the way. All right. Any other questions or comments as we're waiting for the components to filter their way back? Yeah.
What's pros and cons, air assisted versus air?
Yeah, good question. So they're both going to give you about the same transfer efficiency, but the air assisted airless is going to give you higher production. Okay, but the air spray is going to give you a better finish quality. So that's kind of the trade-off. So if you're looking for that really Class A automotive finish, air spray. But if you're painting a farm implement that needs to look good, but it doesn't need a Class A finish and you want to get it painted fast, air-assisted airless is probably the better choice. Does that make sense? Listen, no, I think I got everything. Excellent.
There's a ton of air-assisted airless guns out in the market. Why do you think the electrostatic version isn't more popular?
So you're talking about the air assisted or air spray
like
or any of them?
air-assisted airless gun, right? There's a ton
Yeah,
of them on the
yeah.
market. So why is the air-assisted airless electrostatic gun
Not as much popular. It's the cost of the gun, right? Yeah. And it's the technology. It's just more of an expensive gun to purchase. It's more of an expensive gun to maintain. But I will tell you that if you can sit down and analyze it, these guns can pay for themselves in sometimes days, depending on the cost of the paint, right?
Do you guys have an ROI calculator?
We do. We do. Yep. So it's available on Graco.com. It answered it? Yeah.
I'm on the powder side.
Yeah.
Do liquid, so this is all for it.
Sure.
What, I guess, never heard of electrostatic on a liquid gun. What's the benefit of that?
So
Possibly saving.
it's paint savings, right? If you're going from an air spray application to an electrostatic, you're going from 25 to 35% transfer efficiency, which means 25 to 35% of the paint is on the part and the rest is wasted to atmosphere. And if you're going to electrostatics, that number changes as high as 80%. So a significant difference. That's why I say, if you as a customer are using a paint that costs $80 a gallon, your ROI may be months, it may be a year. But if you're painting with $800 paint a gallon, that might be a couple of days worth, right?
It's very similar to powder coating, except you don't have to cure it, right? So powder has to go in the oven to be cured. Liquid doesn't have to, right? It can air dry from that point. Or you could put it in an oven and also rush cure it also.
Yeah, so I noticed you were saying it's faster.
Well, AA versus air spray is faster. Yeah. Not necessarily electrostatics is faster. Theoretically, it should be because more paint is going on the part, right? Yeah.
Okay, so I was just curious, being on the powder side.
Sure. Yep. But you bring up a really good point because there's a lot of misconception about electrostatics, both powder and liquid in the industry, that says, hey, if I'm getting wrapped, I can paint my part completely from one side. And that's not the goal of electrostatics, right? The goal for electrostatics is to get more paint on the part. You still have to paint completely around it.
The method doesn't change.
Correct.
But you can also do a demo with these on, say, a wrought iron bench and paint from one side and get the majority of the wrought iron
Yeah,
fence
it'll
base.
have some.
Absolutely.
wrap. I
Yep.
mean, just like powder, it'll have some wrap, but
So I put the needle assembly back in the gun. I also put this cap back on. When you do that, make sure you lubricate those O-rings. It's just going to facilitate a better slide with less likelihood of damaging those O-rings. If it's an O-ring, if it's a mechanical slide, grease it. Good question. It doesn't have to be dielectric, but you've got the dielectric grease there. You can use it. It's fine. All right, when you put this back in, this is, I don't want to say dysfunctional, but it's a little disorienting. You're going to put the ribbon cable on, make sure that the terminals go on evenly, and then you're going to slide this from top to bottom. If you push it on from the backside, you're just bending those tabs out. So it's meant to slide right on down and in. Okay? When you're going to push this into the gun itself, if you try and put it in upside down, it's going to feel like it goes in, but this piece is not going to go back on. You're not going to damage it if you put it on upside down. It's just not going to go back together properly. And again, O-ring here, lubricate that. Push it in till it snaps. What's that? Ribbon side down, yep. Okay. Super important when you put these back together at this point, make sure number one, that spring is in place, that spring is in place, that gasket is in place, and there's dielectric grease across the front of this, okay? When you get this gun from the factory, there's probably gonna be dielectric grease all over this thing, right? Doesn't necessarily, you have to get it in the front. You don't have to necessarily do the whole body, okay? All right, gonna slide this back together. One of the things I see people do a lot is when they put this back together, they think they need to get the weightlifting guy out there to torque these screws down. These are plastic on plastic, and so why, number one, why is this gun a resin-based gun? Why is it not metal? Yeah, exactly right. They have to be resin-based because then it would just short the gun out. So because it's a resin base or plastic, whatever you want to call it, you just want to snug these down. You don't have to crank them. There's the lugs in here, and if you tighten the hell out of these things, you're going to pull those lugs out. We've, over the years, reinforced this to make it more difficult to do that, but you just don't need to crank on these. Just snug them down. Make sure that gasket's in place. All right, I'm going to put my needle assembly back in.
Hey, you asked a question about the backup parts and stuff, so is there like a solid cart for the parts, or is there like a kit?
There's kits, yeah. And the kits will be called out in the manual, and your spray equipment rep can help you with what that kit is. All right, next thing is you're gonna put your electrode on. Use some low strength thread sealer here and just put a drop or two on there and tighten this down and hand tighten it and let that thread sealer cure, okay? All right, before we put the nozzle back on, I want to put my trigger back on because I want to be able to pull this back so I'm not grinding those two pieces together. Make sure that little fork is in front of that nut. We're going to put the screws back in. The screws actually screw into the trigger and just land down into the body of the gun.
So it's really not screwing into the gun.
It's not screwing into the gun body, it's screwing into the handle. Yep, correct. Then you want to make sure that when you pull that trigger, you can feel it actually. You'll feel the air valve partial, and then you'll feel it get a little stiffer, and then the needle should follow. Then you can go ahead and put your nozzle assembly back in. And again, you don't have to tighten the hell out of this, just snug it down. And then you can put your air cap back on. When you put your air cap back on, make sure that electrode comes out the center. That electrode will actually, if you get this misaligned, will come out the atomizing hole. And if you tighten that down, what's going to happen? It's going to bend it, and that's when you're going to replace that electrode. And then we can, oops, put our retaining ring back on. And I'll put the fluid back on, and then we'll pass this gun around. Again, when you're all done repairing this, you want to take your resistant meter, check from the base to the electrode, make sure that you've got the right resistivity to this gun. We actually make a voltage, a kV tester that you can, a high pot tester, you can test the output. They're super expensive. If you take a regular mega ohm meter and test this, if it's within the range, it's going to put out the proper kV. Oops. We'll snug that down. I'm going to get this spring return and the cap. And again, everything's just kind of snugged down. The gasket came off, so I want to make sure the gasket goes back in place. Make sure those two springs are there. Dielectric grease on the front. Slide everything back together. And then this is loose on the front of the gun, so I'm just going to go ahead and put my trigger back in, making sure that little fork is in front of that nut. All right, and then the last part, I'm just going to go ahead and pull that trigger back, tighten this guy down. This time I have the tool. And then the filter is going to go back in. These guns are made in the United States out of our Sioux Falls, South Dakota facility. We are not. And we are back together. All right, any last questions or comments? Awesome, appreciate your time this morning.